Hello kids, welcome back. I hope you all have completed the chapter playing with numbers. We are now going to move to the next chapter in this video. So the name of the lesson that we are going to do today is ratio. Now first of all, before beginning with the chapter, let us understand what do you mean by ratio and when do we use ratio. Ratio is used when we want to compare two things. For example, I want to compare my height and my friend's height. How can I make use of ratio? So let me show this to you with the help of an example. So let us write the first point. Why is ratio used? Ratio is used to compare things. Okay, for example, let us say my height is equal to 161 centimeters and my friend's height is 149 centimeters. Okay, these are our heights. My height is 161 centimeters. My friend's height is 149 centimeters. Now, how can I write this data with the help of ratio? I will say that the ratio of my height to my friend's height is equal to 161 is to 149. So I have written our heights in terms of ratio. This is a ratio of my height. Since my height is mentioned first in the statement, when I express it as a ratio, my height, that is 161 centimeter, will come first to my friend's height. Friend's height is second in the statement. So in the ratio, my friend's height will come second. Now these two dots which you all can see here are the symbol of ratio and they are read as is to. So when I read this statement, I will say the ratio of my height to my friend's height is 161 is to 149. 161 is my height is to 149. 149 is my friend's height. Now, this term, the first term in your ratio is called the antecedent. Okay? This is the first term of your ratio and it is known as an antecedent. This is the second term of your ratio and it is called as consequent. Okay, I hope this is clear to you all. When do we use ratio? We basically use ratio to compare things. Now here I am comparing my height and my friend's height. Since in my statement I am talking about my height first and my friend's height second, in the ratio my height is the first term, my friend's height is the second term. Now, besides this, whenever you express something as a ratio, you need to keep in mind some very important things. And I'm going to tell you all about all those important things now. Ratio should always be used to compare similar things. Okay, this is an important point now. Always use ratio to compare similar things. Now, what do I mean by this statement? Ratio should always be used to compare similar things. For example, I cannot talk about my weight and the amount of money that my friend has. That will be wrong. Supposing I tell you all, my weight is equal to 60 kg and the amount of money that my neighbor has, my neighbor has rupees 10,000. Now you can see here children, these are two different kinds of things. One side I am talking about my weight, on the other side I am talking about the money that my neighbor has. Now for such things I cannot make use of ratio. If I say, okay, the ratio of my weight to my friend's money is 60 is to 10,000. I cannot express this as a ratio because they are two different things. One side I am talking about weight, the other side I am talking about money, and this cannot be expressed as a ratio. So always ratio is used to compare similar things. So this is an important rule when you express things in a ratio. The next important thing that you'll need to remember while expressing as a ratio, make sure that the units are same. Okay, so whenever you want to express something as a ratio, you have to keep in mind that the two things that you are comparing are in the similar units. Now let me explain this to you all with the help of an example. Say I have two sons. The age of my eldest son is equal to 9 years and the age of my younger son is equal to 10 months. Okay, now you can see here my eldest son's age is in terms of years, my younger son's age is in terms of months. So if I want to write the ratio of the age of my eldest son to my younger son, and if I say 9:10, this expression will be wrong. I cannot say that the ratio of my son's ages is 9:10. Why? Because they are in different units. One of the age is in years, the other is in months. So what I can do is instead, the age which is in years, I will convert it to months. We all know that 1 year is equal to 12 months. So 9 years will be equal to how many months? It will be 9 into 12, that is 108 months. So what I can do is I can say 9 years is the same thing as 108 months. So I have converted my eldest son's age in months. Now both the children are having age in months. Now I can write it as a ratio. So if I want to say age of my eldest son is to the age of my younger son, how will I write it? 108 months is the age of my eldest son, 10 months is the age of my younger son. So now I can express it as a ratio. The ratio of the age of my eldest son to the age of my younger son is 108:10. So units have to be same. Similarly, if one of your quantity is in kilogram and the other is in gram, you cannot express it as a ratio. You have to make sure that both the quantities are either grams or both are kilograms. Okay, I will explain this to you again when I come to the exercise. So this is the second rule, that they have to be in the same unit. Now, the next important thing that you all need to know is whenever you have something in the form of a ratio, say I have here a ratio 15:20, 15 is the first term, 20 is the second term. This ratio can be written in the form of a fraction also. The first term will be the numerator, the second term will be the denominator. So 15:20 in the fractional form is 15/20. Now just like you can reduce fractions, you can reduce ratios also. Okay, just like you can reduce fractions, you can reduce ratios also. So here I have a fraction which can be reduced. I can say 5 3s are 15, 5 4s are 20. I have reduced the fraction. So this ratio in the reduced form will be written as, in the simplified form, it will be written as 3:4. So just how you can reduce fractions, you can reduce ratios also. Another important thing is you can also get equivalent ratios, just like how you used to get equivalent fractions. For example, you have a ratio 2:7. I can write it in the fractional form first. Write it in the fractional form and I can create a new equivalent ratio from it, just like how we were creating equivalent fractions. I'm going to multiply the numerator and denominator by 5. So this fraction will become 10/35. So this ratio can also be written as 10:35. So you can either reduce ratios just like how you reduce fractions. You can also get another equivalent ratio. How you used to get equivalent fractions from the original fraction. So these things please keep in mind. Another important thing that you'll need to remember, okay, say you want to compare the weight of two bags and I say the weight of my first bag is 5 kilos and the weight of my second bag is say 18 kilo. Express it as a ratio. The first bag is 5 kilo, the second bag is 18 kilo in weight. They are both in kilograms, the units are same. We are comparing the weight of the bag in either case. So how will you express it as a ratio? You will say 5 is to 18. The weight of the first bag to the weight of the second bag is in the ratio 5 is to 18. Now when you write something in the ratio form, remember children, there is no need to put any unit. We don't write any unit over here when we express as a ratio. So ratio does not have any unit. So no writing kilogram, kilogram here. The moment you put this ratio symbol and your numbers are expressed in the ratio form, no putting units. Alright, so these are the basic things that you need to know about ratio. Okay, so having understood this, now let us move to exercise 8A. Exercise 8A, I will begin with question 1. Question 1 says, find the ratio of each of the following in the simplest form. Find the ratio in the simplest form. Okay, this is going to be a rough column. So, the first one says rupees 7.80 to 65 paise. Okay, you have to express this as a ratio. Rupees 7.80 to 65 paise. Now, if you look carefully here, children, the units are different. One quantity is in rupees, the other quantity is in paise. And as I have told you, you cannot express in a ratio form if the units are different. So what we can do here is we will convert everything into paise. Always try to convert the higher quantity. Now here we have paise, here we have rupees. Rupees is the larger quantity, so let us convert the larger quantity to paise. We know that rupee 1 is equal to 100 paise. So how much will be rupees 7.80? If rupee 1 is 100 paise, rupees 7.80 will be how much? So you need to multiply 7.80 into 100. Now how will you multiply 7.80 into 100? When you are multiplying, remove the decimal point, make it as 780 multiplied by 100. You will get the answer. Your answer comes to 00087. Now whatever answer that you get, go back to your question, count how many decimal places were there. Children, we have not started with the chapter on decimals because the topic on decimals has been omitted from the syllabus. Your syllabus has reduced and decimals is not there in the syllabus, in the reduced syllabus. But still whatever is required for your topics ahead, I will be explaining it to you all. So here we are doing multiplication of decimal. You all have learned it last year also, how to multiply decimals. We remove the decimal point, we multiply, and in the answer we put the decimal point back. So we had 7.80 multiplied by 100. What I did was I removed the decimal point and I multiplied. But in my answer, I need to put back the decimal point. Now let us see here, where was my decimal point? It was after 2 digits. There were 2 places after the decimal point. So 1, 2. Since my question had 2 decimal places, my answer also needs to have 2 decimal places and the point will come here. So the answer will become 780.00. So how much is 7.80? Rupees 7.80 I can say is 780 paise. Okay, this answer became 780.00, which means 780. The zeros after the point can be skipped. So rupees 7.80 is equal to 780 paise. Now you can see here, I have converted the rupees to paise. Rupees 7.80 became 780 paise to 65 paise. Okay, now the units have become same. So now I can express it as a ratio. But now go back to the question and see what your question says. Find the ratio in the simplest form. Now simplest form means I need to reduce this ratio. I need to see if it can be made simpler. For reducing, what I will do is I will write the ratio in the fractional form. Okay, I will write it as 780 by 65. And now I will try to reduce. Okay, now since my top number is ending in 0 and my lower number is ending in 5, so I can make use of the 5 times table. So I'll try to reduce this fraction using the 5 times table. I can say 5 13s are 65, 5 1s are 5, put the extra 1 here, 5 3s are 15. So 5 13s are 65. Let us see 780 how we can reduce. 5 1s are 5 closest, extra 2 here, 5 5s are 25 closest, extra 3 here, 5 6 are 30. Okay, so I have reduced and I have got the new numerator as 156 and the new denominator is 13. Let us see if we can reduce it further. Can 156 be reduced with the 13 table? Now here children, again if you all don't know how to reduce directly, I have shown you all the factorization method also, which will help you all to reduce. Now if you all reach here and if you all feel you all are stuck, you all can always factorize the numerator and factorize the denominator to solve the sum further. 13 1s are 13, extra 2 here, 13 2s are 26. Then I can make use of 2 6s are and 2 3s are and 3 1s are. Okay, so I factorize the numbers. Even if you all feel you all can't do this step using the 5 table, you all can factorize like that and get your answer. So how do we reduce using the factorization method? We cancel what is common. So 13 and 13 have been cancelled. Now let us see what is remaining. In the numerator, I have 2 2s are 4, 4 3s are 12. In the denominator, I have 1. Okay, so after reducing, I got it as 12 upon 1. So let us go back and express it as a ratio. We have simplified it. So our final answer, the simplified ratio will be 12:1. Remember children, the numerator is the first term and the denominator is the second term. Okay, now the second sum over here says ratio in the simplest form of 15 hours to 1 day. Again, the units are different. One is in hours, the other is in day. So let us first make them both into the similar units. So the higher quantity is day over here. Let us convert the higher quantity into hours. So hours, how will you convert day into hours? We all know that 1 day is equal to 24 hours. So you will reword this sum. You will write it as 15 hours to 24 hours. So then the ratio will be 15:24. Now you have to simplify it. So write it as a fraction. Simplify it and get your simplified ratio. Okay, the third one says 750 grams to 2 kilograms. Now again here one is in grams, the other is in kilogram. So convert the kilogram to grams. We know that 1 kilogram is 1000 grams. So 2 kilogram will be how much? It will be 2 multiplied by 1000. That is 2000 grams. So you all can write this as 750 gram to 2000 gram. Express it as a ratio. 750:2000. Write it as a fraction. 750 upon 2000 and then try to simplify it. Similarly, the fourth one, 64 milliliter to 1 liter. 1 liter, you all know, convert the liter into milliliter. 1 liter is equal to 1000 milliliter. Convert and then you all proceed. In the fifth one, 18 millimeter to 3 centimeter. So convert the centimeter to millimeter. Okay, 10 millimeter is equal to 1 centimeter. So find out 3 centimeter is equal to how many millimeter? The sixth one, we are given 80 kilogram to 2 quintals. Units are different. One is in kilogram, the other is in quintals. Quintal is the higher value. So let us convert that to kilogram. 1 quintal is equal to 100 kilogram. Okay, children, please remember this. This might be something new for you all. 1 quintal is equal to 100 kilogram. So 2 quintal will be equal to how much? It will be 2 multiplied by 100, that is 200 kilogram. So I have converted the quintals to kilogram. Now I can reword my question. It is 80 kilogram to 200 kilogram. Both are in kilogram. Now I will express them as a ratio. When you are writing as a ratio, don't put any units. Next step, simplify it. Okay, simplify it and get your reduced ratio. Okay, so I hope you all have understood question 1. Question 1 is based on the simple rule that whenever you express something as a ratio, both the quantities that you're comparing need to have same units. In case it is not having same units, you need to make the units same. Always opt for the higher quantity, the higher value, and convert it to the lower value. Like for example, if one is in grams, the other is in kilograms, convert the kilograms to grams. If one is in millimeter, the other is in centimeter, convert the centimeter to millimeter. Okay, so we are done with question 1. Let us move to question 2. Okay, now let us move to question 2. In question 2, you are given ratios and you are asked to express the ratio in simplest forms. So here we are basically simplifying the ratio. We are going to express the ratios in simplest form. Now some numbers over here are simple and can be done directly. For example, the first one is 15:25. How will you do it? First step, write it as a fraction. First term numerator, second term denominator. Now this is a simple number I can directly reduce using the 5 table. 5 3s are 15, 5 5s are 25. So the ratio in the simple form will be 3:5. Numerator first term, denominator second term. Alright, this is okay if the numbers are simple. But let me go to question 5 here. So first one is simple, second one is simple, even third one you all can do it directly using the 9 times table there and further reducing if possible. But if you feel you cannot do this direct reducing, the other method also I will show you all. Let me take the fifth sum. We have 111:259. I will write it as a fraction first. Okay, now say I am finding it difficult to reduce it directly. What I can do is factorize the numerator, factorize the denominator. Okay, take them in the rough column separately and factorize the two things. 111, it won't go in the 2 table because the last digit is 1 and it is odd. We can use the 2 table only if it is ending with a even digit. So I cannot use the prime number 2 to factorize it. Let me see if I can use prime number 3. 1 plus 1 plus 1, the total is 3 and 3 is a multiple of 3. So I can make use of the 3 table. Closest to 11 in the 3 table is 3 3s are 9. But since the number is 11, 10, 11, 2 is extra. I'll put the 2 extra for the neighboring digit. The neighboring digit is become 21. Then I will say 3 7s are 21. 37 is a prime number. I hope you'll know that. So 37 ones are 37. Now let me go to the next number. 259. I cannot make use of the 2 table. Let me see if I can make use of the 3 table. 2 plus 5 is 7. 7 plus 9 is 16. No, 16 is not a multiple of 3. So I cannot make use of 3. I cannot make use of 5 also because it's ending with 9. Let us try the next prime number, 7. 7 closest to 25 in the 7 table would be 7 3s are 21. So I have 22, 23, 24, 25, 4 extra. I can put the 4 to the neighboring digit. The neighboring digit now becomes 49. 49 in the 7 table? Yes, 7 7s are 49. I'll again make use of 37. 37 ones are 37. So my numerator and denominator are factorized. Let us strike off what is common. 37 is common. So we strike it off. What is left in the numerator? 3. What is left in the denominator? 7. Okay. Here 3 is left. Here 7 is left. So when I reduce the fraction, I got 3 and 7. Now, don't forget to put it back in the ratio form. Your simplified ratio will be 3:7. So children, you all have two options. When the numbers are simple, you all can reduce it directly. Do this way. The numbers are slightly big. You are finding it difficult to reduce it. Do this method. This method, please remember, it is very useful even in your 7th and 8th standard classes to reduce the numbers easily and correctly. So I hope simplifying ratios is clear to you all. Now, in the same question, you are also given terms which are in the fractional form and you all are asked to reduce it to a simple ratio. So let me just explain some questions based on that. Okay children, I won't be solving the actual sums which are there in the exercise. I'll take some examples so that you all can attempt the sums from the exercise. Now here you are given a fraction 1/15 which is in ratio with another fraction 1/25. So here the ratio is in terms of fractions. Your first term is a fraction, your second term is also a fraction. And now you are asked to simplify this. So how will you read this ratio? It will be read as 1/15:1/25. And they are asking us to simplify. Now how do you simplify when they are in the fraction form? First step, find the LCM of the two denominators. Okay, I found the LCM. Let me multiply and check out what it is. There is a 3 and 2 5s. So this comes to 75. Okay, first step is to find the LCM. After you find the LCM, your next step would be to multiply each term of the ratio by the LCM. 1/15 is the first term, 1/25 is the second term. Multiply each term by the LCM. So multiply this term by 75. Remember children, the 75 will go in the numerator part. Multiply this term by 75. Okay, find the LCM, multiply each term in the numerator by the LCM. Now let us try to reduce. Let us see if anything can be reduced in the numerator and denominator. So in the numerator there is 75, in the denominator there is 15. Can I reduce this? Yes, I can. 15 ones are 15, 15 fives are 75. I reduce the numerator and denominator. Similarly here, 25 ones are 25, 25 threes are 75. Okay, so I reduced. Now let us see what is left in the first term, what is left in the second term. In the first term, I have 1 multiplied by 5 upon 1, which is 1 multiplied by 5 is 5, 5 upon 1. How will you write 5 upon 1? I had told you all, whenever there is a 1 in the denominator, the answer is always a whole number, which is the numerator. So 5 upon 1 is written as 5 is to, here we have 1 into 3, 3 upon 1. 3 upon 1 will be written as 3. So this ratio in the simplified form will be written as 5:3. Okay, let us just take one more example here. Here we are given fractions and we are asked to make it in the simplest form. But one of the fraction is a mixed number. Now as I have even told you all before, whenever there is a mixed number, always convert it to a fraction. So this will be written as 3 upon 4 is to 5 upon 8 is to 2 2s are 4 plus 1 5 upon 2. Convert the mixed number to a fraction. Your next step will be to find the LCM of all the denominators. 8. Once you find the LCM, your same step goes again. Multiply each term by the LCM in the numerator. So multiply by 8, multiply by 8, multiply by 8. Try to reduce whatever you can. 4 ones are, 4 twos are, 8 ones are, 8 ones are, 2 ones are, 2 fours are. Let us see what is left in the first, second and third term. In the first term I have 3 twos are 6 upon 1. So I will write it as 6. Second term I have 5 into 1, that is 5 upon 1. I will write it as 5. Third term I have 5 fours are 20 upon 1, which will be written as 20. So this ratio in the simplified form is 6:5:20. So I hope so far it is clear to you all. Watch this video and attempt question 1 and question 2 of exercise 8A. Thank you very much. Have a nice day.